AP Calculus AB. This is a particle motion exam problem right off the 2004 free response. It's question number 3, obviously. It says a particle moves along the y-axis so that its velocity v at time t is greater than or equal to 0 is given by v of t is equal to 1 minus arctan of e to the t power. Also says that at time t equals 0, the particle is at y is equal to -1. It tells us here that the inverse of a tan function is arctan, and hopefully we knew that, and we're going to work along with that. This is important too. At time is 0, the particle is at position -1. It says find the acceleration at time is 2. So first we're going to do is find the acceleration at time is 2. So these are the notes that I'm going to be writing for my reader to read. So I'm going to call this problem A. And all I'm going to say, because this is a calculator section, I'm going to say that A sub 2 is the same as V prime at 2, right? Because acceleration is the first derivative of velocity. I'm going to plug that into my calculator. This is exactly how I would do that. If you want to see it, I go to my calculator here, insert calculator, and I would say, what do I want? Acceleration. So I go to menu, I go to calculus, I go to derivative at a point. I'm going to go ahead and let that be the variable be x. The value is 2, right? They want v prime at 2. At 2, I do want the first derivative, so I say OK. And now I'm just going to fill in the blanks here. And it was 1 minus, and then it's right here in trig. If you want arctan or inverse tan is right here. And remember, they want e, so it's this e, not this e here, but this e here, to the power of, and here, because I didn't change it here, my variable, I left it as x, so I'm going to get e to the x, not the t. I'm going to hit enter. Look, it gives me this thing, and you're like, holy crap, how's that going to help me? I can't write that down on the exam. When you see this on your CAS calculator, they're trying to give you an exact answer. But if you need an estimated answer, all you have to do is just hit Control and hit the Enter key, and you get this answer right here. All right? So this is what I'm going to do. I'm going to go back to the problem that I had. I'm going to take this number that I had, go back to the problem that we were working on, and I'm going to put is equal to negative 0.13, was it 2929, or even better, about equal to, and it's fine if you round this to 1.33, it's fine, but this is what they want to see. The answer is worth something, right? The answer is worth something, but they want to see this calculus notation, that you know that acceleration at time is 2 is the same as the first derivative of velocity. So that's what they wanted to see there. So there it is, not bad, right? We go back and we look at problem B, and so we did A. Look at B, it says, is the speed of the particle increasing or decreasing at t is equal to 2? Give a reason for your answer. So I'm going to go over, I'm going to take a look at this. We know this, so B, we know that A of 2 is equal to negative 0.1329. V of 2, what is V of 2? So I'm going to go ahead and I'm going to assess V of 2. You can do it any way you want, but I assessed V of 2 and I got a negative number. So, negative number. This is really important. This is not what I would write to them. If sine of acceleration and velocity are the same, we have increasing speed, right? Then increasing speed. So this is what I'm telling you. This is what you need to know. But that's not what I would tell them. I would just tell them this. I would say this to them. I would say acceleration at time is 2 is less than 0. Velocity at time of 2 is less than 0. Therefore, speed increasing. Circle my answer. Moving on to part C. All right? This is really not that bad. You're going to have tons of time if you have a plan, if you've done enough of these problems, and there's a great chance that you're going to see these problems. I'm going to go back now. Tell myself I've done question B. It says, find the time, t is greater than 0, at which the particle reaches its highest point. Justify your answer. It reaches its highest point. Well, this is what I did here. Again, I went back to here. I went back to my calculator. I already did this. I graphed the function, and look, This is really weird. This is actually how I would do this, just to show you. I don't know if you can see, but there's this place from 0 to right there where velocity is positive. Because remember, we only care about time is 0 and this way, right? After here, all the velocity is negative. And if velocity is negative, it's moving downward, right? So what I'm going to say is this. First thing I'm going to do is I'm going to analyze the graph. I'm going to say, go to the menu, analyzing the graph, and I'm going to find the zeros. And then look, I'm going to put to the left, to the right, and there it is, 0.443. Right? So the question is, reaches its highest point. Well, it reaches its highest point as its velocity is positive. Remember, none of this crap over here matters. Right? So this thing is moving from 0 to 0.443. The particle's moving up. After that, it's moving down. Right? So this is what I'm going to say about that. This is how I'm going to notate this on my thing. Is I'm going to say this. I'm going to say that v of t is greater than 0. The velocity is positive from t is greater than or equal to 0 to less than 0.443. Right? After that, it's negative. And if the velocity is negative, it's moving left. It's moving left, right? So y of t, the position, has its maximum, yt max at t equals 0.443. If you want to, you can say t is greater than 0.443. Velocity is decreasing, right? Or not, velocity is not decreasing. Velocity is negative, or velocity of time is less than 0, right? And if remember, velocity is less than 0, that thing is moving downward. It's changing direction. So that's my whole answer. This is how I answer that part. That gets us to part D, and I think we're actually moving along pretty good right here. Now this one looks really bad, but it's not bad at all. We've got to remember some stuff that we have. It says find the position at the particle at time is 2. If the particle is moving along the origin, blah, 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 blah. Here is where we finally get to go back. And this is kind of, they're messing with us a little bit. We have to remember here that when time started, we were already at -1. We were already at -1. So what we want to know is this. They want to know, where are you at time is 2? So where are you is position. So where are you when time is 2 is equal to -1. That's the start point, right? Because it's, right, start point. Plus the definite integral from 0 to 2 of v of t dt. I'll just plug that exactly into the calculator like that, all right? Of course, you have to enter your function there, but it's going to give you back your answer, and it is at -1.360. So that's where. This is the position. And they want to know, are you moving away from the origin? Well, at time was at v of 2. Remember, we had v of 2 was less than 0, so the velocity is negative, means you're moving left. And the position at 2 seconds is less than 0. So you're moving away, right? Right. We started at -1. At the end of 2 seconds, we were at -1.36. So here we are, here at time is 0, we are here, and we're moving down. So we're moving away. All right, so we're moving away from the origin. So away from origin. Remember to show your calculus. Please remember, the more of these problems that you do, the better you're going to do on them. None of them will fool you. Remember to follow directions carefully, okay? All right. I hope this has been really helpful for you. If you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks, you guys.